So today we're going to be talking about relations and functions. This is chapter 2. And so if you notice up there on the board, I have the definition of a function. And a function is a relation in which each element of the domain is paired with exactly one element of the range. So let's review again what domain and range are. Domain is what? X values. Yes, good. What's the range? The Y values. And so if you look here, this, in order for it to be a function, it says each element of the domain is paired with exactly one element of the range. So now when we deal with functions, we have three categories that these functions can fall into. They can either be one-to-one, they can be onto, or they can be both one-to-one and onto. And so a one-to-one function, if you look at this, says each element of the domain pairs to exactly one unique element of the range. So basically what a one-to-one function means is that you have one x to one y. So a one-to-one function, one x to one y. Each element of the domain is paired with exactly one unique element of the range. Now an onto function, on the other hand, says that each element of the range corresponds to an element of the domain. So the range has to all be accounted for. So I want you to look back at the first one on one-to-one. And I want you to tell me why is the one-to-one function here not onto? Yeah?
Because not all the range has.
Yeah. Not all the range has a value. And so if you look here, that letter C is why that first mapping is not considered to be onto, because that would need an arrow coming to it in order for it to be onto. And then last but not least, we have both one-to-one and onto. Each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element in the domain. When I think about a function that is both one-to-one and onto, you need to think about couples. Okay, you've got couples. So everybody is coupled up in order for it to be both one-to-one and onto. Everybody is coupled up in order for it to be both one-to-one and onto. Now this is found on page 61 of your book, so if you need to look at that, you can. But we're going to go ahead and look at an example. And so if you look here at this first example, it says state the domain and the range of each relation. So the domain and the range. So if you remember, the domain is the x values. So the domain here, I'm going to go ahead and list that. What is my domain going to be?
6.
Yep.
5.
Yep.
3.
Yep.
1. 6.
Yep. So there's your domain. Now what I need to do is list my range. What's my range going to be here, folks?
-1.
Yep.
9.
Yep.
7.
Yep.
7.
Yep. Now, I don't need to list the -9 twice since it's already been used. And so there's your domain and range. Now we need to determine, is this a function? I already used it. Okay, so is this a function? So remember, for it to be a function, x can only go to one y. Okay, so if I look, does this x go to one y? Yep. Does -5 go to one y? Yep. Does -3 go to one y? Yep. Does -1 go to one y? Yep. And does 6 go to one y? Yeah, so this is a function. So yes, it is a function. So we're going to go ahead and write function. Now, if it's a function, we need to determine, is this one-to-one, onto, both, or neither? So one-to-one means that for every x, there is exactly one y. So for every x, is there exactly one y? No. Which is the one that screws up the one-to-one? This one and that one. So that function is not one-to-one because both -5 and 6 go to -9. Now let's try if it's onto. in order for it to be onto, each element of the range has to be paired with some element in the domain. So is that the case? Is -1, -9, -7, and 7 paired with an element in the domain? Yeah, so this one is onto. Oops, let's use pen, sorry. Okay, so that one is onto. All right, let's look at another one. State the domain and the range of each relation. So first of all, the domain. What's the domain going to be here? 2, -1, -2. What's the range? Yep. Yep. Okay. And so now, is that a function, yes or no?
No,
Why is it not a function?
because there's no range.
Yep. Because I see that 2 goes to both -2 and +2. You're also going to see that -1 goes to -1 and +1, so this is not a function. So as a result, we can't even classify it, and we're done. So if it's not a function, you just answer not a function, and you're good to go. Let's look at another one. Here you go, domain and range. So what's my domain going to be?
-3,
Yep.
-2, -1, 0.
What's the range going to be?
0, 2, 4, 6, 8.
0, 2, 4, 6, 8. So first of all, is this a function, yes or no? Yeah, it is a function. The reason being, all of these x's just go to one y. So it is a function. Now we need to determine if it's 1 to 1. So 1x to 1y, is that 1 to 1? Does 1x go to 1y? Yeah, this is 1 to 1. Is it on 2? Is it on onto function? You're saying no, why? You're right. It is not onto. What number throws it off? What number throws it off so it's not onto? 8. 8 doesn't have a buddy. Okay, in order for it to be onto, every part of this range has to be paired up to an element of the domain, and the 8's not, so as a result, that is not onto. Okay, so what we're going to talk about now is what's known as a discrete function and a continuous function. Now, it's maybe not important that you know the formal definition so much as you can identify which one is which. Okay, so if I were you, what I would do is I would put discrete function, and then we're going to put an example of what a discrete function is. Okay, so based on that definition that you read up there, I want you to read the definition of a discrete function. I want you to identify, is graph A or graph B discrete? Which one is discrete? I heard an A here. A? Anybody else A? So everybody, it's consensus A? You're actually right. Basically, a discrete function is one that just has a bunch of dots, has a bunch of points. On the other hand, a continuous function, which is what we have right here, a continuous function is a graph that is a line or a smooth curve. Now, 90% of the time, we're going to look at continuous functions. Okay, then there's that other part of the time where we're going to look at non-continuous functions. But it's important for you to understand discrete means dots. Continuous means there's going to be no dots. It's just going to be like a straight line. So if you think about it, something that was continuous would be like the highways. Okay, you can drive down them without falling. Alrighty, so let's go ahead and look at this next one. This very next thing of what we're going to talk about is the vertical line test. Now, the vertical line test. Vertical line test is used to determine whether a graph is a function, and it's going to be visual. The nice thing about the vertical line test is it always works, and you're going to use it a ton. So first of all, what I'm going to do is I'm going to start with a graph. Okay, and I've got a graph over here. And what I'm going to do now is I'm going to pass that vertical line through the graph. Now, in order for it to be a function, it can only touch that pink line once at any given point. So at any given point, it can only touch the pink line once. So as I move, does it only touch it once? Is there any time where it touches it twice at the same time? No. So what would this be classified as? This is a function. So let's look at the next one. At any given time, does it just touch this pink line once? Yeah, right here it touches it twice, right? Touches it both top and bottom. So this would be classified as not a function. Let's look at this very next one. So, at any given point, am I just touching it once? What happens here? Is it touching it once or twice there? What does that open circle mean at the top? That means it's not equal to, so that's kind of like a hole in the graph. So at this point in time, it looks like it touches it twice, but it actually touches it once because that open circle is not a specified point. Okay? So this one actually is a function. Okay, so now let's go ahead and look at the following question. The following question states, the graph shows the length of the Tour de France in kilometers each year from 2000 to 2009. Is the relation discrete or continuous? So what would you classify that one? Discrete, very good. So we go ahead and answer discrete. Is this a function? So this is what you can do to determine if it's a function. Let's go ahead and draw on our vertical line. Let's go ahead and move our vertical line over the graph. Does it only touch at one point? Yes? Yes? Yep. So, as you notice, it only touches one point. Okay? So, is this a function? Yep. So, this graph is a function. Okay, so let's look at the next one. It says graph y equals 1/2 x minus 3 and determine the domain and the range. So how am I going to graph this? Ideas? What? Solve it? Yeah, it's already solved for x. So here's one way. I'm going to make an x-y chart. What would be 3 good values of x that I could use? I could do 0, 1, 2. I could do -1, 0, 1. The nice thing about using numbers close to 0 is that 1, you don't have to make that big of a graph, and 2, those values are generally small values because they're smaller numbers. So I'm going to take -1 and I'm going to plug it in here for x. So first of all, I've got 1/2 times -1, which is what? -1/2. And I'm going to subtract 3. So what is that? -3.5. Let's plug in 0 in the same spot. If I plug 0 in, I get 1/2 times 0, which is -3 is -3. If you plug in 1, what do you get? -2.5. Good. So now what I'm going to do is I'm going to plot those over here on my xy coordinate plane. So here's y, here's x. Very first point I'm going to start with is -1, -3.5. So I'm going to go ahead and eyeball halfway between. Next one I'm going to do 0, -3. And then I'm going to complete 1, 2.5. So now what I need to do is connect those dots. So there we go. Now based on this, I need to determine the domain and the range. So the domain is like the x values that you put in. Is there any number that I can't put in here? Any x number? No, I can put everything in. So the domain is all real numbers on this one. Now that might not make total sense yet, the domain and the range on this, but we're going to build on that as we continue through the chapter. Okay, what about the range? The range is like our up and down or y-axis. So is there any value along the y-axis that I'm not going to get? No, so this one would be all reals as well. Basically, if you're dealing with a line, one like this, your domain and range are going to be the same. They're going to be all reals. So now I need to determine, is this a function, yes or no? Function, good. Okay, now I need to determine 1-to-1 onto both or neither. So is this 1 to 1? Yep. Is it on 2? Is every y value accounted for? Yeah. Yep. So as a result, this is both 1 to 1 and on 2. Okay, is it discrete or continuous? Continuous. So now what we're going to do is we're going to go ahead and look at another one of those. This one is y equals x squared plus 1. So we're going to go ahead and make our chart again. We're going to use -1, 0, +1. So if I use -1 and plug -1 in there, what you're going to do here is that means -1 quantity squared. What is -1 quantity squared plus 1? 2. What is 0 squared plus 1? 1. What is 1 squared plus 1? 2. So this one's a little different. So if I plot this one, I get -1, 2, which is right here, 0, 1, which is right here, and 1, 2. Question is, what does that look like? Okay. This is what you need to file away to memory. Whenever you have x squared, y equals x squared. X squared is the highest power. You're either going to get a smile or a frown. Okay, so file that away. Whenever you have something squared like x squared, your graph is going to be a smile or a frown. And in this case, it's going to be a smile. And we're going to learn about x squared quite a bit this year. Okay, and we'll talk about when it's a frown, all that good stuff. So now I need to determine, is this 1 to 1? Why not? You're right. It is not 1 to 1 because there are 2 2's. Very good. So first of all, I guess I skipped the question, is it a function? And it is a function because it passes the vertical line test. The function is not 1 to 1 because of the 2 2's. Because of this one and this one. Is the function on 2? Why is it not on 2? 0, -1, -2. So this function is not on 2 as well. So this is actually neither. Discrete or continuous, what do we got? Continuous. Good. Okay. Now it's going to take a while for this 1 to 1 and the on 2 to sink in. So if it's still a little fuzzy, that's okay. Okay, very last thing we're going to talk about, and this is something that you've seen in algebra, so this is nothing new. You don't necessarily need the definitions of the independent variable and the dependent variable. We're going to talk about those. The most important thing on this page is going to be the function notation. Okay? And so first of all, an independent variable is the value of the variable that determines the output. So that's independent of the other variable. Okay, the dependent variable is the value that is dependent. It depends on that person. So think about it. Your parents are the independent, dependent would be you. Okay, so you are dependent upon your parents or your guardian for support, for food, for a roof over your head. Okay, so now function notation. If I look at this, okay, the independent variable is x. The dependent variable is f of x because f of x depends on x's value. And so in this case, it says given f of x equals 2x squared minus 8, find each value. So does anybody know what we're going to do here? Plug in 6 where?
X.
Yep, we're going to plug in 6 for x. So I'm basically going to take whatever is here, and I'm going to plug that in right here. So 2 times 6 squared. First thing I'm going to do, order of operations, is the 6 squared. I know that 6 squared is 36, so I've got 2 times 36 minus 8. What is 2 times 36? 72, so I have 72 minus 8, which is 64. Good job. So now what I'm going to do on this next one is I'm going to plug in the 2y. And I'm going to plug it in right up here as well. So I've got 2 times 2y squared minus 8. Okay, so first of all, 2y squared, I'm going to distribute that squared to both the 2 and the y. So really, what does that become? 4y squared. Now notice I have to take 2 times that. So what is 2 times that going to be? So I have 8y squared minus 8. Can you simplify that at all? Okay. Now the thing here is we can't combine them because they're not like terms. The only way I could combine them is if they both would have y squared or they both wouldn't. So that is going to be your final answer. Okay, I've got one more up here. And the only reason we're going to quickly look at this one is because this one I have to plug in twice. If you notice there are 2 x's, so when I plug that 2.8, I'm going to plug it in here, and I'm also going to plug it in here. So what that means is 0.5 times 2.8 squared minus 5 times 2.8 plus 3.5. Now, we're not going to go through and do that. You can do that on your own. But we're going to look at the next one, 4a. So I'm going to plug that in. So I've got 0.5 times 4a quantity squared minus 5 times 4a plus 3.5. Now, you would be required to simplify that down. But that's what you need to do. You just plug it in for x and you should be good to go. Questions? A lot of stuff we covered. Okay, a lot of stuff. So this is what's going to happen. You're going to have your assignment. Your assignment's actually going to be due Monday. Okay? So I know we've got activities tonight and that. And so this assignment is going to be due Monday. And tomorrow, I haven't decided. I think we might be spending another day on this. We'll wait and see. We might have that or some group work. So anyway, this assignment is due Monday.